Good morning everyone. So in this video we are going to see about tractors and heat engines. First let's see about tractor. What is a tractor? It's a self-propelled power unit having wheels or tracks for operating agricultural implements and machines including trailers. Tractor engine is used as a prime mover for active tools and stationary for machinery through power takeoff, that is PTO or belt pulley. So the present tractor is the result of gradual development of machines in different stages. So let's see about the tractor development. So first in 1890, the word tractor appeared first on the record in a patent issued on a tractor or traction engine invented by George Harris of Chicago. In 1906, successful gasoline tractor was introduced. 1908, first Weinberg tractor trials were held. 1911, first tractor demonstration was held. So between 1915 to 1919, PTO was introduced. Between 1920 to 24, all-purpose tractor was developed. Between 1936 to 1937, diesel engine was introduced in tractor and pneumatic tires were introduced. Next, in between 1950 to 60, manufacturing of diesel tractors on extensive basis throughout the world was taken up. 1960 to 61, tractor manufacture was held in India by first manufacturer Eicher. In 1962 to 1970, manufacturers like tractor and farm equipment, Madras, Hindustan Tractor of at Baroda, Escort Tractor at Faridabad, and International Harvester in Mumbai started working during this period. 1971, Escort Tractor Limited started producing Ford tractors. 1973, manufacture of HMT tractor was started. 1975, manufacture of Pitti and Kirloskar tractor was started. 1975, Harsha tractor was established. 1981, Auto tractor was started. 1982, Universal tractor was established. So between 1983 to 2003, GTCL tractors, tractors, Sonalika, VST, L&T, Bajaj tractors were produced. Next, we will see about the classification of tractors. Tractors can be classified as according to the design, two types, riding type or four-wheel type, or walking behind type or two-wheel power tiller. So based on the traction, tractor is divided into track type. So this track type is again further divided into full tracked and half tracked. Next, wheel type. Wheel type is divided into two-wheel type, tricycle or three-wheel type, four-wheel type. According to the utility, tractors are classified into general purpose, all-purpose tractor, orchard tractor, industrial tractor, garden tractor. Two-wheel tractor. It consists of single axial walk behind tractor, is also known as power tiller, guided by hand and used in rice growing areas. Recently, riding type power tillers have been developed and are being manufactured and have better operator comfort. These are more useful for small land holdings and popular in rice field. In hilly areas, maximum we will be using power tillers. Power tillers are also used for seed preparation, sowing, hauling, pumping, transporting, and other stationary works. Power tiller is equipped with rotary tiller and powered by horizontal single cylinder engine of 5 HP to 15 HP. Three-wheel type tractor. It is also known as tricycle type tractor. Front two wheels of this tractor are much closed, so it resembles like a single wheel. Row crop tractor is suitable for agricultural purpose. The tractor manufacturer Farmall was famous for tricycle type in 1930 to 1970. Four-wheel tractor, a prime mover which is designed to pull, push, carry and operate implements used for agricultural work is farm tractor. This includes row crop, high crops and utility tractors. The row crops and high crops have adjustable threads that allows careful navigation through row crops. It has two large traction wheels at rear and two small wheels at front, used for pulling, tilling, harrowing, planting, pushing, lifting, hauling, transporting, and provide PTO work such as rotation, drilling, harvesting, pumping, thrusting, leveling, etc. Power range of farm tractor is 10 kW to 75 kV and maximum speed is 35 km per hour. Rear roll bar frame and rollover protective cap provided on tractor to prevent the operator from any accident or overturn of tractor. Four-wheel drive or 4WD has been designed to get more traction drawbar power and pull. In such type tractor, power is transmitted at front wheel as well as rear wheel to get more traction and better stability. In this traction, tires are provided on the front also. These may be smaller or equal in size of rear tires. Power range of this tractor is from 15 kV to 100 kV. Track type tractor having limited use in agriculture. A tractor which have endless iron track passing round driving sprocket or pinion are known as track laying or crawler tractor. They have the following operation: commercial orchard cultivation and maintenance, farm operation in hilly areas, land cleaning and earth moving work. Tractor performance can be improved by using tracks rather than wheels and tires. The weight of tractor is spread over a large area between track and soil, thereby improving traction. In agriculture work, more drawbar pull and reduced soil compaction is achieved with crawler tractor. Power range of this tractor is from 20 kV to 100 kV and maximum road speed is about 10 km per hour in agriculture work. Tracked machine is limited to have pull jobs only. Next is utility tractor. First, compact utility tractor. This type of tractor are designed specially for landscaping and land management only. Compact utility is a small model four-wheel drive tractor. Garden tractor used in domestic operation like gardening, grass cutting, etc. They have strong axial frame and transmission. These tractors have very low ground clearance and are designed for light duty works. Orchard tractor. It differs little from utility tractor. Mainly they are used in orchard area. Industrial tractor It is limited to work for loading, unloading, lifting, etc. in industries. Next we will see about heat engine. What is a heat engine? It is a machine which converts heat energy into mechanical energy. Heat is generated by the combustion of fuel such as coal, petrol, heavy oil, or some gas. This heat is supplied to the working substance at high temperature. By the expansion of this substance in suitable machines, heat energy is converted into useful work. Heat engines can be further classified into two types: external combustion and internal combustion. In a steam engine, the combustion of the fuel takes place outside the engine and the steam thus formed is used to run the engine. This is known as external combustion engine. In the case of internal combustion engine, the combustion of the fuel takes place inside the engine cylinder itself. So this is the classification of heat engine. Heat engine is classified into two types: external combustion and internal combustion. So external combustion, example steam engine. Internal combustion is further classified into three types: reciprocating, Wankel, rotary gas turbine. So this reciprocating is again classified into CA engine and SA engine. The CA engine is again classified into 2-stroke and 4-stroke. The same way, SA engine is also again classified into 2-stroke and 4-stroke. Carburetor type IC engine. In this engine, liquid fuel is atomized, vaporized and mixed with the air in correct proportion before being taken to the engine cylinder through the intake manifolds. The ignition of the mixture is caused by an electric spark and is known as spark ignition. Diesel type IC engine. This is only the liquid fuel is injected in the cylinder under high pressure. So this is the construction of IC engine. We will be discussing each components one by one. First let's see about the cylinder. The cylinder of an IC engine constitute the basic and supporting portion of the engine power unit. Its major function is to provide space in which the piston can operate to draw in the fuel mixture or air, compress it, allow it to expand and thus generate power. The cylinder is usually made up of high grade cast iron. In some cases, to give greater strength and wear resistance with less weight, chromium, nickel and molybdenum are added to the cast iron. The piston of the engine is the first part to begin movement and to transmit power to the crankshaft as a result of pressure and energy generated by the combustion of the fuel. The piston is closed at one end and open at the other end to permit direct attachment to the connecting rod and its free end. The materials used for piston are grey cast iron, cast steel and aluminium alloy. Trend is to use only aluminium alloy piston in tractor engine. Piston rings. These are made up of cast iron on account of their ability to retain bearing quality and elasticity indefinitely. The primary function of the piston ring is to retain compression and at the same time reduce the cylinder wall and piston wall contact area to a minimum, thus reducing friction losses and excessive wear. The other important function of piston ring are the control of lubricating oil, cylinder lubrication and transmission of heat away from the piston and from the cylinder wall. Piston ring are classified as compression ring and oil ring depending upon their function and location on the piston. Compression rings is usually plain one-piece ring and are always placed in the grooves nearest the piston head. Oil rings are grooved or slotted and are located either in the lower groove above the piston pin or in the groove nearer the piston skirt. Their function is to control the distribution of lubricating oil to the cylinder and piston surface in order to prevent unnecessary and excessive oil consumption. Next is piston pin. The connecting rod is connected to the piston through the piston pin. It is made up of cast hardened alloy steel with precision finish. There are three different methods to connect the piston to the connecting rod. Connecting rod. This is the connection between the piston and the crankshaft. The end connecting piston is known as small end and the other end is known as big end. The big end has two halves of a bearing bolted together. The connecting rod is made up of drop frog steel and the section is of F-beam type. Next is crankshaft. This is connected to the piston through the connecting rod and converts the linear motion of the piston into rotational motion of the flywheel. The journals of the crankshaft are supported on the main bearing. Housing in the crankcase, counterweight and flywheel bolted to the crankshaft help in smooth running of the engine. Next is engine bearing. The crankshaft and camshaft are supported on anti-friction bearing. These bearings must be capable of withstanding high speed, heavy load and high temperature. Normally, babbitt, cadmium, silver or copper lead is coated on a steel back to give the above characteristics. For single cylinder, vertical or horizontal engine, the present trend is to use ball bearing in place of main bearing of a thin shell type. Valve. To allow the air to enter into the cylinder or the exhaust gas to escape the cylinder, valve are provided, known as inlet and exhaust valve respectively. The valve are mounted either on the cylinder head or on the cylinder block. Camshaft. The valve are operated by the action of camshaft, which has separate cam for the inlet and exhaust valve. The cam lifts the valve against the pressure of the spring, and as soon as it changes position, the spring closes the valve. The cam gets dragged through either the gear or sprocket and chain system from the crankshaft. It rotates at half the speed of the camshaft. Flywheel. This is usually made up of cast iron and its primary function is to maintain uniform engine speed by carrying the crankshaft through the interval when it is not receiving power from the piston. The size of the flywheel varies with the number of cylinder and type and size of the engine. It also helps in balancing rotating masses. So thank you. This is the end of our video.